with the same amount of pollution, you're going to get a higher smog level. And that's the concern. This is just reporting from, and I have down there, if you haven't got it, you can get it off the website, from impacts to adaptation, Canada changing climate, the natural produced by, or sponsored by Natural Resources Canada, published in 2007. This is some quotes out of the British Columbia chapter. As it notes, most of the British Columbia population are less acclimatized to 30 degrees C. Air pollution increases in Greater Vancouver. And they talk about increasing heat stress, exposure to air pollution, illness, absenteeism, hospitalization, premature mortality. Other things they talk about is the water shortages. I've already referred to that. The changes in available precipitation in the summertime, but deluges in the winter. And that will be effect since BC gets over 90% of its energy from electrical energy from hydropower. How will that affect the availability of hydropower, particularly in the summertime as we have warmer conditions, more needs for air conditioning if we go that route, and hopefully we don't, but anyway. These are just some of the points they make on their frequency and intensity of extreme weather events, floods, storms, coastal erosion. Big concern in this area, sea level rise. I used to live in Tawasin. I chose to live on a high rock. That was in 1986 or so when I moved to be a UBC professor, and without thinking about the politics of this, I was quoted in the local media said, as a climate scientist, this was in 1986, I did not want to live in Richmond because I didn't want to be flooded out by sea level rise. I was called by the Richmond Town Council and asked to appear and explain myself. And my advice then was, this is nothing to panic about, but is something to start consciously thinking as you build your diking systems, you do your land use planning, that eventually the sea level will be higher. With more storms, that's a concern, and you should start doing something about it now. Somebody from the local media called me about this last summer. I can't remember who it was, only a few months ago, and they were going to check whether Richmond had actually done that, and maybe the Richmond engineer is here to tell me they have. I think they have, but I'm not sure. Anyway, so sea level rise, climate change does really need to be integrated into the infrastructure planning, life cycle management to reduce the vulnerability of BC's critical infrastructure. I was in Kyoto, Japan last week for a major meeting on science and technology and society. The two major points of discussion were climate change and information and communications technology. And the Japanese put on the table their document, Wise Adaptation to Climate Change, and just thought it was interesting to see what the people across the ocean are looking at. And the Japanese have a major report out. It doesn't have a lot of detail in it, but I put some of the bullets down here just for information. They start off by saying you should do regional vulnerability studies. Well, to some extent we've done that, but we need more of that for BC. What does it really mean to Surrey for climate change, not averaged over BC? Early warning systems. They recommend using a diverse range of options in mainstreaming adaptation. They talk about efficient and effective realization of low vulnerability, flexible and responsible systems. Now, I must admit I'm not 100% sure what the Japanese mean by that, but that kind of approach of flexibility, responsive systems is important. Looking for co-benefits. Areas where you do something because it gives you the benefit of reducing, for example, air pollution as well as greenhouse gases, but it also gives you perhaps a more energy efficient house. You save energy costs, but at the same time you may be making it more climate friendly. So there's work being done in various places around the world that we can build on. This is from California, the same meeting, the people from California presented the first results of their regional vulnerability assessment. I don't expect you to read this, but they went through for California and identified the biggest issue is water. And they'll be looking for water from here if they can't get it there. So some of the policy issues, municipal planning, changes, recognizing the changes in sea level, flood zones, availability of water, building codes, stronger winds, rain we're going to have, energy design, recognizing that more extreme events with hot days, heavy rain, etc., the need for early warning systems, emergency response. We have in Canada quite a mix of bag of people, quite frankly, who do emergency preparedness response, from the local level to the provincial level, somewhat the federal level. In many cases, it is contracted to people like the Red Cross, as community volunteer organizations. And how do we, I'm on the Red Cross's advisory committee. They've said they've identified climate change as a big concern to them. How much more stress will they have on their volunteer systems they run in terms of being ready for the kind of events that will happen with climate change? Community adaptation, as I said, rethinking infrastructure, economic policies. I think you should also look on it as a development opportunity. There will be both nationally and globally opportunities for development, looking for opportunities of investment, new ways of doing things. So climate change is not necessarily all bad. A warmer climate in the winter may not be that bad for certain kinds of things. So think through, where are the opportunities as well as the negatives? I work for this Institute for Catastrophic Loss Reduction, which interestingly was set up by the Canadian insurance companies. Insurance Bureau of Canada in 1997. Its members were hit very heavily by mostly U.S. storms, and then we had the Saguenay flood, $1 billion. The ice storm cost the insurance companies $1.7 billion, and the Canadian society over $7 billion total. So the Insurance Bureau of Canada, then senior economist Paul Kovacs, set up this institute. They got some money to hire some people like me. They convinced the universities to hire people like me, so I'm part of the institute though. And we're doing a number of things, like retrofitting of homes, mostly demo projects. I've been to schools in the Greater Toronto area where we've done simple things like just make sure that bookcases are properly fastened so they don't fall on the children if a tornadic wind comes through. We get lots of tornadoes in Ontario, about 18, 20 of them a year. Retrofitting for safer homes. We have another project which is called the Insurance Research Laboratory for Better Homes. And if you go out to London International Airport, that's London, Ontario, the other London as we usually say, this thing is a house, two-story Canadian house. This thing slides over it, and they put thousands of pressure gadgets all over it, and they basically can create the wind pressures of a tornado, a hurricane, a winter storm, and they can turn on the hoses to create a deluge of rain, and they shake and vibrate this thing until it breaks somewhere. And they look to see where it breaks and figure out, well, okay, if we designed it differently, how would we have had a better job? Interestingly, we worried about how we'd get the first house built, and then Fanshawe College construction students said, well, we'll build it. And as soon as we built the first one, and it's a frame, what do they call it, a brick veneer wood frame house, the steel guys said, aha, we'll show you our house is better. So they're going to build the second one. And the concrete construction guys have now lined up and they're building the third one. So it'll be a concrete block house. So anyway, you can get interesting intersections of the private sector and things in this kind of thing. We also have at the University of Western Ontario the Boundary Layer Wind Tunnel, which is Canada's foremost wind engineering program. That's one reason why this institute is there, because that's actually the Sears Tower. They do the wind engineering on basically every major building in the world and every major bridge. So we have an engineering competence in Canada, and there's people at UBC who do similar kind of things. We've been working with the U.S. group called the Institute for Business and Home Safety, and you can pull up our website things like Fortified for Safer Living. How do you design a house that is more resilient to everything, including earthquakes, which you're prone to around here? And again, we've done some demo kind of projects on this with, and there's been actually the insurance companies that part of our board have, in a couple of cases, have said to people, when they went for reasons where if a house is totally destroyed, they have to rebuild it. What we're trying to get them to do is give the homeowner the option of rebuilding a fortified home as opposed to just the ordinary home. It'll cost a bit more, but the agreement is to kind of split the costs. So a number of things are happening, and I think at this point I should get on to the next speaker, so I'll end with my usual picture of the polar bear who's on thin ice. I'm not quite sure how he actually got like that. I've been using this picture for years. I have no idea where I actually got. But anyway, I thank you for your attention, and we'll welcome some discussion with the other speakers also. Thank you.